not only is there an engineering problem to solve here, but there are also legal issues and then accounting issues in terms of the tax credit.
If it's basically just pipes and pumps, why shouldn't a city consider creating its own district geothermal utility that would provide heating and cooling to its main train station and to a nearby housing development? In May 2026, Stephen Winter, Executive Director of Climate and Sustainability for the City of New Haven, Connecticut, and also a state legislator, joined me for a deep dive conversation about this very cool municipal geothermal network project. I'm John Farrell, Director of the Energy Democracy Initiative at the Institute for Local Self-Reliance, and this is Local Energy Rules, a podcast about monopoly power, energy democracy, and how communities can take charge to transform the energy system. Stephen, welcome to Local Energy Rules.
Thanks. Glad to be here.
I love asking this question of my guest in that role of climate sustainability for city and as a state legislator. Are these answers to the questions someone might have asked you as a kid, what do you want to do when you grow up? Or has the path been a little more winding in terms of getting you to where you would like to be?
That's a great question. I think the only documented answer, as far as I know, of what I wanted to be when I grew up was I wanted to be a garbage man because I saw them going by on the truck. And they always were outside, which I loved as a kid. And they always looked like they're having a good time. So in my current role, I do get to interact with the refuse and recycling division somewhat as we try to improve recycling. And we're also looking to set up a food scrap diversion program in the city. But I think in a larger sense, I was always interested in public service, and a lot of the work that I've done professionally has centered on public issues in one way or another, whether that's the software entrepreneurship you mentioned, or prior to this role, working for the city as part of the mayor's office. I worked as a board of alders member, so a local city council person, you might call them, in another jurisdiction. And I've always been interested in how we can solve big problems and how the government can play a role in doing that.
That's great. Well, it seems like you've landed in a good place for that. And I have to say that garbage man, the nice thing about trash, as we talk about at the Institute for Local Self-Reliance, is that it's fundamentally a local issue. So even if you're not doing that specific work, although it sounds like some of your work is related, you certainly are in the right place doing public policy and working with local officials. I should also say too, if you want help in the local food scrap collection side of things, ILSR has a lot of work on community-based composting, and our colleagues have some terrific model policies and other things. I'd be happy to connect you.
Neat. Okay. Yeah, that sounds great.
Well, let's talk about the project I invited you on to talk about, which is a really cool project, a network geothermal project that will be serving New Haven's Union Station and also some nearby housing units. I was hoping you kind of give, very big picture, 10,000 foot view. Just talk about some of the benefits of the project. Like, what does it mean for energy costs and pollution impacts for the buildings that will be using it? Are there other benefits that you tout or that the city is touting in making this investment?
Yeah, so this project was inspired by the work that's going on in Framingham, Massachusetts, the Eversource Thermal Energy Network pilot that's up and running in Framingham, as well as work that's going on more locally. Yale University is setting up their campus district geothermal, which is privately owned and operated, but definitely got us thinking big about, could we do something similar on a city block scale that could provide clean heating and cooling? And the Housing Authority of New Haven had acquired several years ago a large series of parcels across the street from the city's main train station, which was previously home to several hundred units of affordable housing that essentially went through demolition by neglect. And so we knew that they had plans to redevelop that parcel, and that they had begun a choice neighborhood planning grant process through HUD for the neighborhood that's centered around this collection of parcels. So we thought, wow, this would be a great opportunity for the city to provide a climate solution that's also an affordability solution that could be a model for clean heating and cooling in the city, and ideally expand beyond the new housing to the surrounding neighborhood in the long run. So that's morphed somewhat in the last couple of years. So we applied and were awarded a climate pollution reduction grant, implementation grant from the EPA in 2024. And since then, the housing authority's redevelopment plans have really come into focus. So in the near term, in the first building, there'll be about 300 units. And then in the second building, another 400 or so units. So in total, 750 units spread across two buildings directly across the street from the train station, with future phases bringing the total number of units as high as 2,500 units. So it's a really large scale development, especially for Connecticut. And our vision is to try to provide clean heating and cooling to as many of those units as we can afford with the grant funds, plus funds that the city will borrow and be reimbursed for through the federal investment tax credit. So although the wind and solar tax credits are being wound down, the federal tax credit for geothermal, commercial geothermal, is extended through 2032 at its full value. And so we plan to utilize that to cover, we're targeting 40% of the project costs. It's possible that it could be larger than that if we're able to get an additional brownfield designation credit for the project. So all told, the project budget should be in the neighborhood of $16 million. And the bulk of that goes towards developing a ground loop. So the bore field series of geothermal wells that are connected by lateral pipes and a large heart, essentially a big pump system that moves fluid through the wells and through the main line where buildings connect to the system. And those buildings would include as much of the train station as we're able to decarbonize within the project budget. And that's going to depend on an analysis that we're just planning to get started on with the parking authority that manages Union Station. So there's several different heating and cooling systems within the building, and we'll look at which we can move off of fossil fuels first. But we're going to provide capacity through that connection to the main line so that in the long run, we can move the whole building off of fossil fuels. And then the other buildings will be those buildings that the housing authority is building that I mentioned on what's being called the Union Square site. So we're really excited about that. And we're working with the housing authority now to define the parameters for the billing structure, essentially, for paying for thermal energy from the network, and looking at other models in North America for municipally owned heating and cooling utilities, and think that there's a good analog for us outside Vancouver. I believe it's called Richmond. There's an clean heating and cooling network geothermal analog outside of Vancouver called the Alexandra District Energy Utility, which is in the city of Richmond, British Columbia. And they provide geothermal heating and cooling to a series of connected buildings based off of the size of the building, so the square footage that's being heated and cooled, the amount of thermal energy that is being pushed into the system in cooling times or pulled out of the system in heating seasons. So that's an important conversation that we're fleshing out now with the housing authority. The vision is that the system will be municipally owned and operated either by the city or by an entity that's governed by the city and the stakeholders. So the housing authority or future condominium owners of the housing authority properties, and Union Station, which the city leases from the state and works with the parking authority as the station manager.
So I was hoping you could describe a little bit about how the heating and cooling works for folks who aren't familiar with geothermal. So you dig big holes, these wells. There are pipes that go down in them. You're essentially grabbing the heat that's underground and it gets absorbed into the liquid that's moving through these pipes. It comes into the building. What happens then?
Yeah, so with a large building, typically it would go through a plate heat exchanger where the fluid that's circulating through the geothermal network, which is typically a mixture of water and glycol, like an antifreeze, it goes through a series of metal plates, and that exchanges heat with another water source loop on the building side. And that On that side, there would be pumps that circulate the fluid to heat pumps within the building. And those heat pumps can provide space heating and cooling as well as domestic hot water. So you're utilizing the relatively stable temperature of the circulating fluid to provide heating and cooling through the heat pumps. And that's much more efficient than using an air source heat pump that relies on refrigerant and has much greater swings in temperature. So the ground year round is hovering around 55 degrees, and using that as the base energy source for your heat pump is much more efficient than if it's negative 20 out and you're needing to run a heat pump. We can do that now, which is awesome. We can run an air source heat pump. Many models can operate at those levels, but the efficiencies are going to be greatly reduced versus that ground source system. And the other thing I would stress is that over the course of a year, we want to keep that ground resource, so the big rock formation and soil above it that the buildings sit on and that the geothermal wells are situated in, we want to keep that in balance over the course of the year. So it's important, as the system's designed, to have a sufficient number of boreholes that each year you're ending the year more or less where you started, and that over time you're not heating up that geologic formation or cooling that geologic formation. So the ground loop of the series of boreholes really acts like a thermal battery. And so keeping it in balance is an important part of designing the geothermal system.
And that happens this issue of balance is related to how in like a cold weather climate, you're going to spend more time in the year drawing heat out of the ground than, for example, the few summer months where you're going to be putting heat back into the ground out of the buildings, for like air conditioning. So you're designing the system to account for that, essentially, is what I'm hearing.
Yeah, that's right. So do you want to look at whether the building profiles are cooling dominant or heating dominant? And then your domestic hot water can help balance that, because you're going to be heating that up throughout the year. So if you're in a cooling dominant building and you have domestic hot water, you in some situations have a smaller number of these boreholes because you need fewer boreholes to remain in balance, because the hot water wants to pull heat out and the cooling dominant building wants to push heat in. So it seemed kind of counterintuitive, but was something that I found really interesting as we're going through the design development process for this, that you'd think, oh, well, if I'm extracting more heat, I'm going to need more boreholes. But it really has more to do with balancing out those heating and cooling loads.
I feel like the lesson I've learned from some early conversations is this is a great case for more publicly owned ice rinks. Because if you could just get an ice rink on every thermal loop here, you have someone who always wants cold.
Yeah, no, that's absolutely right. I keep thinking, yeah, if only we had thought to do this over by our ice rink, we'd be in business. So,
well, now you have an idea for your next project. There you go. I wanted to come back to something you talked about, figuring out the billing for this, and I just want to emphasize how interesting that conversation must be, because of course, right now, most people in urban areas in the US, or even people on delivered fuel, you're paying for a volume of fuel. Usually on your bill will say something about BTUs, and it's based on the heat content of the fuel. So like natural gas, propane, whatever, you burn it for heat. And the reason we use those fuels is, of course, you get a fair amount of heat out of burning 1 unit of that energy. Now you're selling heat, but you don't actually have anything you're selling. It's not a physical product you're selling people that they combust. You're just selling the heat that comes through their house and goes into that heat exchanger. How fascinating. And as you pointed out, you're selling something that you hope remains in balance from year to year through the design of the system. So it's not exhaustible either. So you have to figure out how to price this appropriately. You're still delivering a service, which is heating and cooling, but you're not pricing it on the basis of the fuel anymore.
Yeah, that's right. You're really pricing it more based on what you think the long-term operations and maintenance costs of the system are. So you'll want to have somebody who's on call, probably a contractor in our case. If there is some sort of issue with the pumps or other equipment, you'll be looking at replacing key components of the system over time. So if a pump has a 15 or 20-year lifespan, you're going to want to be budgeting to build up to be able to replace that equipment. There's some filtration of the glycol fluid that's in the system. And then there's still utilities associated with the system, right? The pumps run on electricity. And so you'll be looking at that as well as maintenance costs, and then building in some reasonable margin of safety, and then figuring out how to spread those costs over the user base. But the goal at the end of the day is that we're still going to be less costly than you would have been if you were building a similar building with an air source system for heating and cooling or for domestic hot water. That's really the goal, is that we're going to have an all-electric building, but we're going to have the most affordable option for residents, both the affordable units that'll be part of the new construction, as well as the market rate units, so that everybody in that building is going to be benefiting from lower electric bills and the stability, right? That like over year, you're not going to be seeing wild swings in the price of oil or the price of natural gas. It really is affordable and predictable, which I think we can all agree, over the last year, over the last 5 to 10 years is also worth a lot.
Yeah, absolutely. I'm curious to hear how the project is going. When I last read about it in December, it sounded like drilling on the boreholes had gone faster or more efficiently than expected, meaning that the project might actually need fewer of them. I don't know if my read on that was accurate. So I'm kind of curious, like, what's the status of the project?
We are coordinating the final layout of the bore field with the housing authority to confirm that, since we're sort of a step ahead in the design development process, we will begin construction before the housing authority does. So we want to make sure that we're coordinating where our system will go, so that we don't get in the way of the construction of the new buildings and the construction of all the other utilities that will need to serve those buildings, like stormwater, water, electrical. So we are finalizing those layouts, and then we're also working with the housing authority to determine the best strategy for the investment tax credits. So once we have those issues finalized, we should be able to finalize our construction plans. The bore holes that you mentioned, those were test bores, and we completed 2 test bores, one to 850 feet, which is a pretty standard depth in our part of the Northeast. So most of the boreholes at Yale University are 850 feet. In our case, we also completed a second borehole that was 1,250 feet. And our plan is to go with the 1,250-foot boreholes because we'll be relatively space constrained with the new construction. Our plan is to go deeper with fewer boreholes and get the same amount of heating and cooling capacity, but with larger bores. So we did discover between the first shallower borehole and the second deeper borehole that the bedrock is considerably deeper as you move closer to the train station and towards Long Island Sound. So that was one thing we learned during the drilling process. So those test bores can help inform which type of drill rig makes the most sense for the project based on the depth to bedrock and the composition of the bedrock.
These are, I find, just absolutely fascinating engineering questions. One of the other ones that I was thinking about was, you kind of alluded to earlier that hopefully in the long run, you can expand this system maybe to additional buildings or additional blocks that would be nearby. I assume that when you do that, you will drill additional boreholes, or is there some degree to which you're oversizing the system now to prepare for that? Or will you sort of do it incrementally as you sign up new buildings or new spaces, you would drill the boreholes?
So our plan is to oversize the main circulation line and to give that main circulation line capacity for additional bore fields to be added onto the system. So in the beginning, we're looking at this central plaza. In the main parcel that the housing authority acquired is basically a triangle. So in the center of that triangle, And then each corner of the triangle will have a building. So that's where the first bore field will go. But we're also laying out locations for future bore fields. There's a bike path that runs along one side of the triangle, one leg of the triangle, and there's a relatively wide median next to that. So we could potentially have a second array of bores underneath that bike path and in that median. And that could serve the third building that will come online and potentially part of the heating and cooling load for additional buildings beyond that. And there's also a plan to narrow Church Street South, which is currently 2 travel lanes in each direction. So to cut the number of lanes in half and have 1 travel lane in each direction, and then have a wide pedestrian boulevard heading essentially from the train station and the new housing development towards downtown. So depending on what gets constructed first and how quickly the housing authorities buildings go up, that could be an opportunity to place additional bores underneath that pedestrian promenade.
I'm sorry to ask you very specific questions about drills and rigs and things. How big is the borehole? Like, how far across is the hole that they're drilling?
That's a great question. And you might be surprised to learn that it's about 6 inches. So it's not a very
Oh, wow.
wide hole, but it's in the middle of a roughly 25-foot diameter circle. So that's how we're thinking about spacing these out. So you have a relatively narrow bore, and then 25 feet later, another one. So they are spread out quite a bit so that they can conduct heat through the rock formation. But the holes themselves are not terribly wide, but they are very deep.
Oh, that's so interesting. I have always pictured them as being at least like a couple feet wide. So this is actually really helpful.
Yeah, and in that 6-inch hole, as you go through the overburden, which is the soil above the bedrock, typically there's steel casing. That's the tube around the hole. And then when you hit the bedrock, you insert the casing into the bedrock and continue drilling, but you don't need to install casing because you're now in the rock. And then within that 6-inch wide tube, which is either surrounded by the metal casing or the rock formation, you then have a plastic pipe. In most cases, it's one pipe going down, then a plastic U, and then another pipe coming up. And that's grouted into place. And the grout helps with absorbing and diffusing heat. And then the fluid is pumped down and goes through that U bend and pumped back up. So at its core, it's pretty simple. It's not like, there's lots of electronics or something like that buried hundreds of feet beneath the earth.
We are going to take a short break. When we come back, I ask Stephen how his role in the city's Board of Alders and his position in the legislature have impacted this project. I also ask why they didn't work with the incumbent gas utility and what advice Stephen has given to folks in other cities about doing similar district geothermal projects. You are listening to a Local Energy Rules podcast with Stephen Winter, Connecticut State Legislator and Executive Director of Climate and Sustainability for the City of New Haven, Connecticut. Hey, thanks for listening to Local Energy Rules. We're so glad you're here. If you like what you've heard, please help other folks find us by giving the show a rating and review on Apple Podcasts or Spotify. 5 stars if you think we've earned it. As a bonus, I'll gladly read your review aloud on the show if it includes an energy-related joke or pun. Now, back to the program. That simplicity is part of its strength. Okay, I'm going to stop asking you questions about engineering and U-bends because I want to ask about the role that you play at the city in the sustainability role. You were also previously on the city's governing body. You mentioned the Council of Alders or City Council to those of us from other places, where you helped set some goals for electrifying buildings. And in the legislature, I noticed you're also on the Energy and Technology Committee. So I was curious if you have been able to influence the course of this project or support it through those legislative roles.
At the local level, my tenure on the Board of Alders ended when I took the job with the city. So there isn't really an overlap there. But I think that the electrification resolution we passed, setting a goal to electrify the city's buildings and its vehicle fleet by 2030, which I think it's tough, especially with the fleet. It's been a lot slower than we expected when the goal was set. The amount of EVs and the breadth of use cases isn't what we hoped it would be. But I think that was important in terms of engaging the public and in educating our legislative body about why that kind of a goal is so important for public health and air quality reasons, for reducing operating maintenance costs from city's physical plant and its vehicle fleet. And I think that it's been good grounding for us as we've embarked on this geothermal project. At the state level, we have secured an authorization for a thermal energy grant and loan program through the Department of Energy and Environmental Protection. So they're authorized to set up a grant and loan program to help develop thermal energy networks like the one that we're developing in New Haven. We need to get some funding to really get that process started. So in Colorado, in New York, in Massachusetts, similar grant and loan programs that have funded everything from community planning and feasibility to system design and even construction have only really gotten off the ground when the state government has set aside some amount of funding. And on the small end, it could be as little as $50,000 for planning and feasibility. That's the model that Massachusetts has taken with their community planning grants. On the larger level, it could be a cost share in the case of New York or grant in the case of Colorado that helps with the phase that we're in, the design development process, to help a project where you have buy-in from stakeholders but need to do the design and engineering work. And in Colorado, I think they've also helped to some degree with construction and implementation. So I'm hopeful that we'll be able to convince the governor and other leaders in the legislature that this is worth setting aside some dollars for and helping other communities, particularly in the downtown areas, make these kinds of investments. So there's interest in Manchester, Connecticut, where they have done 3 net zero schools, and they're just bringing online now the geothermal heated library. They're planning to do a major road reconstruction project downtown. Their municipal buildings are heated by low temperature hot water systems, so they would be excellent candidates to hook up to a geothermal system. It would be great to support a community like that with planning and engineering dollars so that they can figure out, okay, how are we going to finance this and what will it take to construct it? And that can, I think, is an ideal case because you have municipal buildings as anchor tenants, so to speak. And then you have other commercial uses along the loop that now have a new resource available when their furnace or their boiler is aging out. They have a new resource that they can tap into for a clean, affordable, predictable heating and cooling. And then Willimantic is another community that's really interested in this. They're sitting on top of an aquifer, and there's several large institutions in the area that have already tapped into geothermal. So there's a history there and an interest in using this as an economic development mechanism to help reinvigorate their downtown area. So I think there's some real appetite for this. And I think we can spread this model from New Haven to other communities around the state where there's local buy-in and where residents and community members feel like, hey, this makes a lot of sense. It's very context dependent, I would say. You wouldn't want to just plop one of these down anywhere. But I think with the right context, it can make a lot of sense. And we want to help those projects come to fruition.
When you talked about funding, my understanding is Connecticut has one of the best green banks of any of the states. Has it been funding or supporting these projects already, or could it?
Oh, gosh, I should have mentioned that already. So our plan for the investment tax credit is to get a bridge loan from the Green Bank. And that would be a relatively low interest loan. Originally, we were going to utilize Greenhouse Gas Reduction Fund dollars, which are tied up in court. They were rescinded by the Trump administration. But the Green Bank has a 4.25% loan that the city can utilize. And you might ask, well, you're a city. Don't you have the ability to just bond for these funds anyway? Like, why make use of the loan in the first place? And the answer is that the investment tax credit is reduced. There's a haircut for municipal borrowers of 15%. So if you would have gotten $100 worth of tax credits back, or in this case, a direct payment back, it's reduced to $85. But if you're borrowing from a green bank, in this case, we'd be able to get the full value back. So we are planning to move forward with a loan from the green bank, and they've been really supportive. This is the first loan of this kind with a municipality that they've done. So it's been a slow process figuring out the legal details of the loan agreement, but we made a lot of progress with them and are planning to close the loan agreement later this year. And that'll give us the full complement of funding we need to begin construction, ideally next year on the ground loop. And then the following year, the in-building retrofit work that we'll need to do to move at least some of the train station onto the geothermal system.
One of the things you mentioned Framingham, and so I was curious about, other communities in the Northeast have been relying on the incumbent gas utility to partner with them in doing these kinds of projects. I'm kind of curious what you see as the trade-offs. In the case of electric utilities, for example, a publicly owned utility has often meant that there are lower rates and better reliability than with for-profit companies. Was there an option even on the table for this project to be done with the incumbent utility, or is this something that really just the city decided to pursue because you was largely with city-owned property or like public authorities?
So currently in Connecticut, gas utilities don't have authorization to operate thermal energy networks. And I think that's something the state ought to look at reconsidering. But in our case, we had this unique opportunity where we knew there was going to be this brownfield public housing development, and that the city and the housing authority would be really transforming this corner of the city. And so we thought this was a really great opportunity to try to seed the development of a new municipal utility. And I do think that there's an argument to be made that with a system like this, we've seen similar systems, whether it's water or sewer, operated by regional or local utilities, competently at a reasonable cost, and that we could do something similar with this geothermal utility, which is, largely pumps and pipes. So, yeah, I think there is excitement about having a municipally owned and operated entity. And in our case, the alternative isn't legally available for the gas utility to be involved in owning and operating a system like this. We are looking to the Energize Connecticut incentives to help pay for some of the heat pump costs. There's some incentives for ground source heat pumps. They're not tremendously large, but they could help somewhat. And then we're in discussions with Avangrid, the parent company of the gas and electric providers here, and the State Department of Energy and Environmental Protection about district incentives. So there is a district incentive that the state authorized, but it's never been used before. So our district project, and then there's a district project in Bridgeport that utilizes a fuel cell, waste heat from a fuel cell to provide heating and cooling to part of Bridgeport. Those would be the first projects to utilize this district incentive, so that we're hoping that we can work with the gas and electric utilities to help defray some of the project costs with those incentives.
That's great. Have you spoken with leaders in other cities who are either inspired by, maybe even hoping to replicate this project? And I'm kind of curious what lessons learned that you might have shared with them.
We've met with folks from Chicago. We have presented on the work that we're doing at the New York Geothermal Conference, specifically around this, municipally led work and the work that we're doing with the Green Bank to finance it. And we've presented to the Connecticut Thermal Energy Network, a group that's been meeting about this, that People's Action for Clean Energy has convened, which is called TENS for CT, or 10 for CT. So yeah, really, really excited about all that and spreading the word about how folks might get something like this started and where it might make the most sense.
Is there anything I should have asked you about this cool thermal network project that I didn't, that you think people would want to know about?
Hmm. Anything you should have asked for or should have asked about?
Reporters ask me this question all the time and I never have an answer for it. So sorry to put you on the spot.
Oh, that's okay. I do think one of the lessons from the Framingham project in terms of the costs involved is that a big proportion of it in Framingham was the retrofit piece. So in our case, that was part of what drove us to think, well, where could we look at new housing development and supporting new housing development with a municipal thermal energy network? So I think that's been an interesting thing that helped us settle on this location when we were pitching this project to EPA and to stakeholders at the city. And I think in our case, there's a challenge of wanting to, like, as I mentioned before, we're trying to coordinate our design process with the housing authority's design process. And if you're space constrained, you really can't get out too far ahead. So we've had to slow down our process somewhat to try to get closer to where they are to make sure that we're designing something that's going to make sense for everyone and not cause headaches. And I think that one thing that I didn't really think about was just the importance of the pump house. Where will these large pumps actually live? And I learned early on in the process that that's actually kind of a big picture decision for a project like this, because it's expensive to excavate and put that underground. So for a while we were looking at that, and the housing authority didn't want a big pump house in the middle of their new plaza that's going in across the street from the train station, right? I don't think that would have made sense. There was actually an existing pump house building next to the train station, but the train station's planning to repurpose that space as part of the project that the DOT is leading to redevelop the platform. So redo the platforms, the train station platforms. So where we settled was we're going to construct the pump house, and then the housing authority will essentially build their building around it. So it'll be accessible through a door on the side of the building and take up what otherwise probably would have been a couple parking spaces in the first floor parking podium, or it'll be adjacent to a commercial space, but not taking up too much space. So I think it's actually been a relatively large challenge for us is like most of this stuff is underground, but there is this tip of the iceberg, which ends up being logistical or practical problem of where do you put it? Where does it make sense? What will it look like? In our case, the plan is to essentially hide it within one of the new buildings. So that's just been something that maybe is a sort of in the weeds, but has been a challenge for us, something for us to unpack. And then I think the other thing that is important to keep in mind is just that not only is there an engineering problem to solve here, but there are also legal issues in the case of the Green Bank loan agreement, and then accounting issues in terms of the tax credits. So you do need to make sure that you're thinking about including space in the project budget for tax advice to make sure that you're actually able to claim the tax credits, because the tax credits are really key to making this work. And then another big picture learning is geothermal is one of the more expensive ways to provide heating and cooling to a building. So folks also want to be thinking about what are other more readily available resources. And in this case, given where we picked, there wasn't a great resource available, but I am really interested to meet with our sewer authority at some point in the future and look to see, are there places where there's large volumes of sewer flow and where you could tap into some of that sewer heat. And I think that's a really valuable resource that's flowing right beneath our feet and would pair really well with a system like this. As we look at clean heating and cooling, that may be an important resource for us to tap into, even if it's not something we gravitate towards naturally.
Absolutely. Well, Stephen, thank you so much for joining me to talk about this really amazing geothermal project. It's actually really helpful to hear you get in the weeds about some of the things that you had to consider, both like what you've learned from the process so far, or even just sort of that idea of the thermal balancing needs and how to design systems. I just think this is going to be so helpful for folks who are interested in this technological approach, interested in how cities can get involved in it, but really wanting to understand how to wrestle with it. So, really appreciate the time you took.
My pleasure. And I guess I would make a plug for we brought on an owner's representative company called Aztec Geothermal, who has been super helpful in helping us get educated and navigate all these geothermal specific issues. Because our city engineer has done a residential system. He did his own geothermal system at home, but we haven't done a large scale project like this. So I think if you're getting further along in that project development arc, having someone who's a geothermal wizard to help guide you, I would recommend that as well.
Very good. Thank you so much for listening to this episode of Local Energy Rules with Stephen Winter, Executive Director of Climate and Sustainability for the City of New Haven, Connecticut. On the show page, look for a link to news stories about the New Haven Network Geothermal Project and to my interview with Matthew Mendisco about another project in Haven, Colorado. We'll also have a link to ILSR's Clean Heat Resource page, which includes a brief video about how this approach to building, heating, and cooling solves some otherwise very thorny problems. Local Energy Rules is produced by myself and Ingrid Burson, with editing provided by audio engineer Drew Berschbach. Tune back into Local Energy Rules every 2 weeks to hear how we can take on concentrated power to transform the energy system. Until next time, keep your energy local, and thanks for listening.